Whew. Oh. Okay. So in 1700, Leonard Euler, and when I say Euler, he actually, his name was, when you see it, it looks like Euler, but it's pronounced Euler. One of the most prolific mathematicians of his time, of that century. And up until the 1900s, the last century, when we say prolific, he wrote more on mathematics than anybody else. He revolutionized all of the notation that we use for mathematics. Okay. He ended up creating the equal sign because of him. Function notation, f of x, g of x, h of x, just s of y. It's another simpler way to represent equations so you can make substitution. And when you have multiple equations, they're not all called y. And it makes substitution easier instead of like having to go, okay, you can always go y sub 1, y sub 2, y sub 3, so 3 different y's, but now you need to plug in multiple points. Let x equal. Let y, let x sub 1 equal. Let x sub, you can just say, all right, we want to plug in -1. So f of -1, you're going to replace this x with a -1 and plug it into the appropriate function. Now, as he got older, he ended up going blind. And you got to understand something. There's mathematicians, in the realm of mathematicians, I'm like here. But when you get to real mathematicians, the genius level, like Euler and Newton and Einstein, those guys, they just live and operate in different worlds. They're wired differently. Social skills are almost non-existent. Euler was going blind and his house burnt down. Where he lived. Lost all of his writings. And back then, he didn't just get to print books all the time. So he was able to, from memory, recite his texts to an assistant who then proceeded to rewrite everything that he had watched. And they just blew it away. I couldn't tell you what I did on this. Maybe last night. Last night was different. Last night was flaming. But certainly couldn't tell you what we had Monday. But that's that level. But along comes in the 20th century, 1900s, a man by the name of Paul Erdős. Okay, he's from Hungary, Jewish, Hungary, not Hungary, my belly's gonna rumble, but Hungary, the country. Hungary? Well, Hungary was the name of the country. Is it Hungary? Is it Hungary? I don't know. I'm getting recorded here. I'm gonna be like an idiot. Is it Hungary? She said, yeah, he would be Hungarian. Anyway, he is now the most prolific mathematician who's ever. He's written more on the subject of mathematics, all sorts of different pieces of mathematics than anybody else. And here's what's interesting about Paul Erdős: no social skills. He would show up at a professor's house, another university professor's house, all of his belongings in a paper bag, and just uninvited, unannounced, and just say, "Can I stay here for a week and do a couple of lectures?" And he would just kind of move in with that family for 1 or 2 weeks. He didn't learn how to tie his shoes until he was like 14, because his mom did everything for him. One of the stories that I read in his book was his biography. He was thirsty one night, staying with his friend. So he goes down to get this carton of orange juice, and he doesn't know how to open it. So he takes a knife and stabs the orange juice carton open to pour it out. And he doesn't clean it up. It's somebody else's job. He was also very sick. That's wounds. But there's orange juice all over the refrigerator, all over the ground, but he didn't understand. He doesn't know how to move it. the simple things of life, but he's an incredible mathematician. So in terms of writing, there are Erdős numbers. If you co-author side by side a paper with Paul Erdős, you have an Erdős number of 1. If you co-author a paper with someone who co-authored a paper with Erdős, so 1 removed, your Erdős with an Erdős number of 2. And if you co-author a paper with someone who co-authored a paper with Erdős, so you're twice removed, then you Erdős number of 3. Okay, but it's just amazing what those brains are capable of and what they can't do. Einstein married his cousin, divorced his wife, married his cousin. Okay, now in the reenactments of his reason why, it was because she cooked good sausages. He didn't care about the entire dynamic of a relationship. In fact, his first wife was a mathematician, but he didn't want to share the spotlight with her because she kept wanting to work with him and he didn't want to have any extra time with her. And so a little too needy. I don't want to. And so I think the new wife was Elsa, and she cooked the sausages. Stephen Hawking divorced his first wife, who took care of him. You saw the movie, okay? And then he still got married 2 more times after that, while he was, incapacitated on a respirator in his wheelchair, unable to speak. Married his nurse. I think one time he married his nurse. I don't know what the second time or the third marriage. Okay. I don't know. He is a very amazing person. I mean, just the mind is in there. The body doesn't work. Okay. If you ever get a chance to see Theory of Everything, Eddie Redmayne played Stephen Hawking, and he won the Oscar for it. It's an amazing movie. And when you think about it, would you trade that inability for your body to do anything, but your mind is capable of basically you are at the highest level of thinking on the planet? I don't know. I honestly don't know. You're trapped. And he kept doing what he loved. I mean, he was supposed to die like in the late 60s, and he lived until just 2017 or 18. That's pretty good. And then one last guy, Isaac Newton. Story says, died a virgin. He was so just focused on work. It's just work. Okay. But he is also considered to be one of the greatest of all time. There are the 3 greatest mathematicians who have ever lived: Archimedes, okay, Isaac Newton, and Johann Carl Friedrich Gauss. If you ever do anything in physics, you're going to hear the name Gauss all the time. Gauss is considered to be the prince of mathematics. That's his title. But anyway, because of Euler, we have the function f of x. This function with respect to the variable x. And you can make any name. F is just the name of the function. It's not a variable. It's just the name of the function. This is Freddie. Over here you have Giuseppe. Over here you might have Hugo or Hector or whatever you want to call it. But it's just h of x. Now, when you move on to calculus, the position of an object at any given time, s of t, with respect to gravity, the name of position is s of t. Why s? I don't know. I really don't know why they use s, but typically in calculus, if you measure the height of an object with respect to time while it's flying through the air based on gravity alone and your initial velocity, it's equal to -1/2 gt squared plus d naught times t plus s naught. When we say not, s sub 0, not being for nothing. Okay. This is the acceleration due to gravity. It's a constant. On Earth, if you're using feet, it's negative. Well, technically, if I have a negative there, it's already going to be, it would be a double negative. We don't want that. So because gravity pulls you to the Earth, which is down, gravity is negative 32 feet per second, negative 32 feet per second squared. If you're using meters, it's negative 9.8 meters per second squared. The initial velocity is the velocity that you launch the object to, because it's not going to go up unless you put some velocity into it. And s sub 0 is the initial position. From what height above the ground? Ground is 0. From what height above the ground does it launch from? The path it's going to take, because that's a t squared, anything that's a square is a parabola. So it will always make that parabola curve. When you get into calculus, and something that we actually are going to just kind of dip a toe into, the derivative of the position function, which is slope, derivatives are slope, is the velocity of the object at any given time t. If I take the derivative of this function with respect to time, in other words, what's the change of a position with respect to the change in time, we can get the velocity of the object at any given time t. And that would just equal it would just equal gt, negative gt plus v naught. Okay. And then if you take the derivative of the velocity with respect to time, you get the acceleration of the object. And that's just going to be negative g, which is just the only acceleration happening on the object is gravity pulling it down. Gravity is not a force. Gravity is an acceleration. Gravity is an attraction between two masses. And that's a Newton thing. Okay? But we have these function names. Function names. So we can distinguish between which one is which. So in your quiz on Monday, 2 questions. The first question is going to go through the grouping of 31 through 46. And I'm going to start with 33 as an example. Try him. Oh. So we're given that h of t, the function h with respect to the variable t, is equal to t squared minus 2t. And we're supposed to evaluate h of 2, h of 1.5, and h of x minus 4. A, h of 2, and then B, h of 1.5, and then C, h of x minus 4. So the first one, h of 2. Just So if I replace this t with a 2, I replace every t with a 2. And it's just substitution. Do yourself an incredibly huge favor. Just substitute. Your first step is just substitute. Don't try to be all, hey, I got this. I'm going to substitute at the same time in my head. I'm going to simplify it. I'm going to replace the t with a 2. Whatever I plug in for t, it's supposed to be squared. I know we all know that 2 squared is a 4, but just substitute. It's not always going to be that simple. And what you want to create is good habits. Here's another good habit. When I make a substitution into something like this squared, parentheses, 2 squared minus this t is going to be a 2, so 2 times. Now I'm going to replace that t with a 2, so minus 2 times a 2. Just substitute. It's a good habit. So now h2. 2 squared is 4, minus 2 times 2 is a 4. So h of 2 is 0. The input, the domain, we plugged in 2. The output, what came out, the range, is 0. Remember, domain and range are x's and y's. So when we use function notation, we're actually creating ordered pairs. 2 goes in and 0 came out. It's an ordered pair. Because now you're going to be able to graph functions because you're going to get ordered pairs, domain and range every single time. For B, h of 1.5. So now you're going to replace the t's with 1.5. That's going to be a 1.5. If I replace that t right here with a 1.5, I got to replace every t with a 1.5. So the first t becomes 1.5 squared minus 2 times 1.5. Now, the only time I would allow decimals as an answer is if you're given decimals to start the question. So since we're plugging in decimals, it's okay to use decimals. H of 1.5 is equal to, this 1.5 squared is 2.25 minus 2 times 1.5 is 3. H of 1.5 is equal to negative 0.75. Now, you're not told to write it as an ordered pair. I was just showing you what it looks like. X that went in, the domain that went in was a 1.5, and what came out was a negative 0.75. They didn't ask you to do that. I just wanted to make sure you understand that that's what happens. Okay. Again, I got stories from the 80s. This next one causes all sorts of trouble. This next one is the make or break calculus. If you can get and understand how to do this next one, calculus is going to, it's not going to be easy. Maybe it will for you, but we do a lot of stuff, stuff that looks like this in calculus. So back when I was graduate from high school, my first stop, I went to UCLA as a freshman, and my goal was aerospace engineering, but at UCLA they had something called the freshman summer program, which means they selected, I don't know, maybe 700 of us incoming freshmen, And they put us up for 7 weeks. It was all free. Put us up in the dorms. I was in Sprout, room 580. See, I can remember my dorm room. I can't remember what we had for dinner Monday, but I can remember my dorm room from, 30, 40 years ago almost. My roommate, Alvin Cantero Pastrana. But anyway, freshman summer program. And we took 2 classes, and the rest of the time was being acclimated from living away from home. And we took a pre-calculus class, and I took a computer class. We had back then computers. It was not like I had now. Anyway, in the math class, the lecture was about 400 students. One professor, 400 students. And then after the lecture, you go to the teaching assistants, the TAs. And the TAs would work with the homework and ask questions, and that's where you would go for that. And I remember the TA's name. We had Don, Matt, and Daisy. There were 3 of them. Daisy did the reading. She was reading all the homework. She would grade all the homework. Don and Matt were basically they were master's students, MA students, and they're trying to get their master's degree, so they did the TA so they could get credits. Matt did most of the teaching. Matt was helping us try to plug stuff in like that. But we're sitting there going, what are you supposed to do? So he said, it's a function, it's substitution. So when you plugged in 2, the t's became 2's. When you plugged in 1.5, the t's became 1.5's, and then you evaluate. So let's just say, instead of a number, whatever you plug in, it doesn't matter what you plug in. Let's say you wanted to go H of happy face. So I'm going to replace this T right there with a happy face. That means all the T's get replaced with a happy face. Therefore, that T squared is now happy face squared minus that T is a happy face, so minus 2 times the happy face. Whatever you're going to replace T here with, all the T's get replaced with. If you can simplify, you simplify. If it was, find, evaluate, H of scary monster, and you would draw a scary monster like that, then it's just replace that with a scary monster, replace that with a scary monster. So now it's scary monster squared minus 2 times scary monster. So whatever you're substituting, it replaces the T's everywhere or the X's everywhere, whatever the variable is. So when you come to this, whatever you replace this T with, you're going to square it minus 2 times it. So if I replace that T with an X minus 4, this T is going to get replaced with an X minus 4, and that T is going to get replaced with an X minus 4. So it now looks like this. And this is why creating the better habit of using parentheses when you substitute is going to pay off. T squared, it better be in parentheses, X minus 4, because you're squaring a binomial. And then minus 2 times. If you just put X minus 4, you're not going to do the distribution like you're supposed to. It's 2 times that whole thing. Parentheses when you make the substitution. All right, now you got to simplify. So if you need to ask, I'm going to hold you to ask it. But here's my assumption. We're all past like algebra 2 at some point. But that doesn't mean everybody remembers it. Because I know I need to teach this over and over again, even at the highest levels, because people think one thing and it's not. H of X minus 4 equals X squared minus 8X plus 16 minus 2X plus 8. I'll wait over here. First. You guys good, or you need to see what happened? So this x minus 4 squared is not just square root of the x squared of 4. It is x minus 4 times x minus 4. That's what it means when you square it, which means you got to FOIL it out, which means basically FOILing is distribution. Every term in the first parentheses has to be distributed to every term in the second parentheses. So this x times that x gives me x squared. Then this positive x times a negative 4 is a negative 4x. So that first term has been distributed to both. So that first term is done with a multiplication. Now you have to distribute the second term. Negative 4 times x is negative 4x. And then negative 4 times negative 4 is positive 16. And then when you simplify this, there's only one term that is x squared. You have two terms that are x to the first, negative 4x and negative 4x. They add up to a negative 8x in the middle. And then you have a positive 16, which has no x. And then for the second part over here, it's negative 2 times the parentheses. So we distribute negative 2 times x and negative 2 times a negative 4. So a negative times a negative gives me a positive, 2 times 4 gives me 8. And you're still not done because we still have to combine like terms. So h of x minus 4 is equal to, so we look for all the x squared terms and combine them together. Well, there's only one. Now, here's something that I do. I want to put all my x squared in one basket. Well, that's the only x squared that you have. So I check it off. It's like my wife giving me a shopping list and I'm going around the supermarket checking things off as I put them in my basket. All the x squareds, gather them all up. The next thing on the list is x to the first. There's an x to the first, there's an x to the first. So I want to put them all together. I have negative 8 of them. There's a negative 2, negative 8x, negative 2x, that's a negative 10x. And I check them off. So now I know I've got the x's taken care of. Now I have x to the 0. X squared, x to the first. X to the 0 is your constants. Positive 16 and positive 8 is a positive 20. Yes.
This one we get the Punnett square. We're gonna do
Say again?
the Punnett squares. It's really you square. You do a square and then it back to no.
You can do that, but
There's another way.
I just don't know if you want to draw a square every time you make it. Every time you need to do something like this.
Yeah, that's what high school taught us, but
I know, it's like, and eventually you're going to have to let go. It's like, you got training wheels on. And eventually you're going to need to know that it looks like this. What I did in my head, okay? I mean, that's a really good visual way to see it happen. But what I did in my head was this. You have the three major products for binomials. You have a plus b, and you square that. You have a minus b, and you square that one. And then this one is really important, a plus b times a minus b. Okay? Now, at this level, you should be able to do these kinds of, squares in your head and not need to do a box or need to even FOIL it out. However, you want to make sure it's right. So there are times I will do it in my head, but I will also write it out to make sure it's right. Here's why the answer to this is a squared plus 2ab plus b squared. Because when you do this, you get a plus b times itself. And if you're going to multiply times itself, again, distribution. The first term times each one, a times a, is a squared. And then a times positive b is a positive a times b. So you distributed the first term. Now you have to distribute the b. B times a is the same thing as ab. B times a is exactly the same as a times b. That's the commutative property of multiplication. You can switch the order. 5 times 3 is 15. 3 times 5 is 15. You can change the order of this multiplication. So that's an a times b. And then b times b, that's a plus b squared. So gather all the a squared in one basket. There's only one of them. In the middle, you have one AB and another one AB. So one of them plus one of them, there's 2 times AB in the middle. And then the only B squared in the expression is one of them. So when you have A plus B squared, here's what you do. You square the first term, A squared. You multiply these two together, A times B, you multiply them together. In the middle, you double it. Multiply A and B, and you double it, and then it's addition. And then the last term is your B squared. If it's minus, the only difference when you have minus is A squared minus the 2AB in the middle. It's still plus B squared. That's what I did right here. I square the first term. It's A times B, so X times 4, so that's a 4X. And then you double it, and it's a minus. So 2AB in the middle. And then you have a plus the B squared, plus a 4 squared. So X squared minus 8X plus 16. Okay. When you have the same terms, A and B, but the signs are different. You got a plus here, minus there, or maybe it's a minus and a plus. The answer is going to be A squared minus B squared. This is a really important special one because we call this the difference, subtraction, the difference of 2 perfect squares. Okay. There's nothing in the middle because when you multiply this out, A times a positive A times a negative B is a negative A times B. So you've distributed that first A. Now we distribute B to both of those. Positive B times A, so it's a positive. B times A is the same as AB. And then here you have positive B times negative B. So a positive times a negative is a negative. B times B is B squared. And then look what happens. You have the A squared. In the middle, a negative 1AB, a positive 1AB add up to 0. They cancel out. So there's nothing in the middle, and all you have left is a minus B squared. So if you have x minus 5 times x plus 5. The terms are exactly the same. So it's going to be the first one, the x squared, and then minus the second guy, 5 squared. So that's just x squared minus 25. Right? And even more important than being able to multiply it out quickly and going a squared minus b squared is when you see a squared minus b squared, knowing that factors that way. Because again, when we teach you how to do one thing, in Algebra 1, we teach you how to multiply these things out. But then in the next chapter, we teach you how to factor them apart. So it's about recognition, special products. All right. Now 33, 39. So 39 is another one of those that happens in calculus quite often. Well, 39, the function f of x is equal to the absolute value of x divided by x. And for A, we want f of 9. For B, we want f of negative 9. And for C, we want f of t. So if I replace this x with a 9, all the x's get replaced with a 9. So f of 9 is the absolute value. We're going to replace that x with a 9, absolute value of 9, and replace the bottom with just a 9. Then you got to simplify. So f of 9 is equal to the absolute value of 9 is 9 over 9, and 9 over 9 is what? 1. So when you plug in 9, you get 1. For negative 9. So up here, absolute value of negative 9. Down below, just negative 9. So f of negative 9, the absolute value of negative 9, positive 9. Down below, it's still negative 9. So f of negative 9 gives you what? Oh, wait, negative 1. A positive over a negative, going to be a negative. 9 divided by 9, negative 1. And then don't overthink the next part. All they want you to do is plug in t for x. Replace the x's with a t. So if I replace the x's with a t, or a happy face or a scary monster, f of t is equal to, that's now absolute value of t over t. And that's all you have to do. Yeah, because you don't know what t is. It's something that tastes incredibly horrible. I gag every time someone gives me tea. Take it. It's not t, it's absolute value. You haven't taken the absolute value yet. Look over here. When you plug in 9, yeah, you get 1. But on the other side, if you have negative 9 over negative 9, that's not negative 9. If you go positive, you get negative. Okay. In calculus, we deal with this function a lot because we talk about this absolute value of x over x when we deal with continuity versus discontinuity. When is a function continuous? When is it discontinuous? Okay. This function would be considered discontinuous at 0. Because at 0, you have the function from the left side, negative 1. On the right side, it's positive 1. And they're broken. There's no connection between those two graphs. If it's a continuous graph, they're connected to each other all the time. But on this function, it would look like this. So it's discontinuous. Okay? Three. Is a piecewise function. F of x equals, and it's a piecewise function because it's written as two pieces. X squared plus 2 when x is less than or equal to 1. And it's 2x squared plus 2 when x is greater than 1. So let's talk about something real quick, because we're going to run into this question. Domain. Domain is either implied or explicit. Implied or explicit. Over here, they don't tell you what x is allowed to be. They're not giving you anything. They're just giving you the function. Your job is to be able to look at this function and know by looking at it what the domain is, what consists, what are you allowed to plug in and what you're not. It's implied. It's implied that you know. When somebody talks to you and here's the word, they don't explicitly tell you what you're supposed to do. They don't give you the explicit directions. Do this at this time. They just say, you know what, this afternoon you need to do this. They don't tell you what time you're supposed to do it. They just expect you that you're going to take care of this. It's implied. At some time this afternoon, you're going to take care of this. You know better. But if they say at 3 o'clock, you have to, that's an explicit direction. You're told explicitly what the domain is for a function. A piecewise function has an explicit domain. The first piece, x squared plus 2, is only used if you're plugging in x's that are less than 1. If you're plugging in x's, and remember, domain is the x's. If you're plugging in x's that are bigger than 1, that's explicitly told, you're going to plug it into the second piece. Piecewise functions are part of life. Okay. Sound barrier. Okay. When you break the speed of sound, Mach 1. The speed of sound is not constant. Sound travels at different speeds dependent upon the atmosphere, how thick the atmosphere is. The denser the atmosphere, the faster the sound is, because sound is a wave that propagates through the air molecules in the air. That's why in space, no one can hear you scream. Because in space, there's a vacuum, you can't hear anything because sound needs a medium to vibrate. When I speak, my vocal cords are vibrating, and it vibrates the molecules in the air, goes all the way to your ears and vibrates the tympanic membrane, which sends an electrical impulse to your brain and it turns it to what I'm saying. So you might be hearing blah, 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 blah. You might be hearing the Charlie Brown's teacher, wah, 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 wah. I don't know. But the idea is, for the speed of sound, here on this, at sea level, this is as thick as the atmosphere is going to get. But when they first broke the speed, the speed of sound, sound barrier, in 1947, Chuck Yeager in the X1, Bell X1, which he nicknamed Glamorous Lettuce, it was at an incredibly high altitude because the air is thin up there, sound travels much more slowly. So you don't have to go as fast. Now, back then, jet planes were just kind of coming into their own. You couldn't take off in that plane from the ground to break the sound barrier. They had to drop it from a bomber. The bomber would take it up and then would drop it like a bomb, and then he would flip on the jets, and basically he had 4 jets, 4 of those, if you ever saw the movie Right Stuff, he would flip them on and he would just kind of, with each one, more thrust. They had no idea what was going to happen because everybody who tried to break the sound barrier did not survive. That's why test pilots were the ones that kind of paved the way. The sound barrier has been broken on the ground. So up in the air, it's like 650 miles per hour. But here on the ground, they had to do it at 700 miles per hour. Out there on the Salt Lake, the salt flats in Salt Lake, or in Utah salt flats. They have those rocket cars. There's been a couple of guys been able to do it. But you got to go 700 miles an hour because the air is so thick. Okay. That's a piecewise function. The speed of sound is a piecewise function. All you do is plug in the altitude. It's a different velocity depending upon if the altitude is 0 to so many feet in the air, or that feet in the air to the next feet in the air, and then this feet, you plug it into a different equation. Is that like 5 or 6 different levels? That's piecewise. So all you have to do for here is get to know it. We're not even going to graph it yet. That's coming later. You have to do, come on, let's go. No. We're doing -2, 1, and 2. -2, 1, and 2. So f of -2. So the first thing you got to say, okay, where's -2? Is -2 less than or equal to a 1, or is it greater than 1? It's actually greater than 1. It's less than or equal to a 1. So I'm going to plug -2 into the first piece, into this first function. So f of -2 is going to go into this one, and watch. This is really important because if you do this on a test or a quiz, if you do this, -2 squared plus 2. If you do that, and the next line is this, f of -2 equals 4 plus 2. I'm going to do this to you. How? Why? Work does not justify answer. Because -2 squared is -4. -2 in parentheses squared, that's a positive 4. What have I said more today than I've said anything else? Use parentheses. When you write it like this, -2 squared, the only thing being squared is the 2. It's -2 times the 2. The negative is not being squared, only the 2 is. So you have a -2 times 2, that's a -4. When you replace the x with a -2, that means you're supposed to replace everything here and square the whole thing. You should have put it in parentheses. So you get -2 times -2. Now you have a negative times a negative. Now that's positive. And I'm not trying to be mean, I'm trying to be a jerk. I understand what you think it's supposed to be, and yeah, technically you might be right, but what you're writing is not correct, so I am trying to make good habits. Because eventually it's going to bite you in the behind. Okay? So now you have a positive 4. Use parentheses. So f of a negative 2 is equal to a 6. F of 1. The first piece or the second piece? Where's the 1 going to go? The first piece, if you're going to plug in an x that's less than or equal to 1, use the first piece. If you're going to plug in an x that's bigger or greater than a 1, you plug in the second. 1 is the first, because that's where the equals 1 lives. If you're plugging in anything that's less than or equal to 1, and I'm plugging in 1, it goes into the first piece. So f of 1, and I know this is like really, you gotta show all this. I'm just talking about good habits. Whatever goes in, you're going to square it. So parentheses, good habit, even if it's positive. 1 squared plus 2. F of 1 is 1 plus 2, so f of 1 is 2. Like the equals over here.
Do you ever have an equation that has like that wouldn't have the top equation as like the last equation?
Oh, so there's no equals.
Do we ever have one like that?
Yeah, you could, and that just means that function, if you talk about the domain, you have use this if you plug in numbers less than 1, use this if you plug in a number greater than 1. So what happens at 1? Well, 1 is not in the domain. You don't get to plug in 1. So the domain of the function would be all real numbers. You got less than 1, greater than 1, except you don't get to use 1. Everything but 1, because there's no equals on the 1. What you could never have is this. You could never have this is less than or equal to 1, and this is greater than or equal to 1. Because now you have it, which one do I plug in 1 into? Because you can't plug 1 and get 2 different y values. So that would never do it. But yeah, you can have, and that would be an example of, here's a function that at x equals 1 would be discontinuous because there's no point. There's no connection right there. The function would look like this when you get 1. Might look like a hole, and then somewhere else it just continues me. But you have a gap or you have a hole. So which one does 2 go into? The first or the second? 1 and 2. So it's 2 times. X is now a 2, and you're going to square it, and then a plus a 2. F of 2 is 2 times, that's a 4, and then plus 2. 2, 8 plus 2, 2, 10. Now 46. Forty-six is a 3-piece piecewise function. Got 3 pieces. We have 5 minus 2x. If x is less than 0, we have 5. If 0 is less than or equal to x, which is less than 1, and we have 4x plus 1 if x is greater than or equal to a 1. And we gotta do -4, 0. So they're kind of being real kind because, so far, like A has been in the first piece, B's been in the second piece. C's usually been in, well, in this case, C will be in the third piece, maybe. It's kind of been given to you nicely. You could never always depend on that happening. Because honestly, we could have just mixed all this up. We could put this one f of -4 as part B, put f of 1 as part A. So just pay attention to what you're doing. -4. So which is -4? Is it less than 0? Is it between 0 and 1? Or is it greater than 1? So it goes into the first one, less than 0. So you plug -4 into 5 minus 2x. F of -4 is 5 minus 2 times -4. So f of -4 is 5. A negative times a negative is a positive, so that's +8. So f of -4 is equal to 13. Then part B, 0. Is 0 less than 0? Is 0 greater than or equal to 0 but less than 1? Or is 0 greater than or equal to 1? And the second one, because that's where you have to equal to 0. First of all, 0 is not less than itself. But right here, 0 is in between 0 and 1 and or equal to the 0. That's where 0 is. Okay. Look at the function. F of 0 equals whatever you plug in for x, no matter what on this interval, whatever you plug in. Do you see an x right here? There's no place for you to actually replace x with 0. There's nothing to put in. The function is always 5, no matter what on this interval. The answer is 5. It's a constant. So real quick, side note, if I gave you g of x was equal to -4, and I ask you what is g of 3, what is g of -8, what is g of pi? If I plug in 3, exactly, no matter what I plug in, there's no x over here. I can't replace anything over here with whatever x is because there's no x. Whatever goes in, the answer is going to be -4. If I plug in 3, oh, okay, -4. If I plug in -8, well, that's all you have, -4. If I plug in pi, well, -4. What g, what f, what the function name replaces? It replaces y. Instead of y equals -4, the function notation replaces the y. They are simpatico, they are interchangeable. So this g of x equals -4 is the same as y equals -4, which takes us right back to last chapter or last section. If y is by itself, it's a special case. If y is by itself, it looks like an upside down h, which means it's just a horizontal line at -4. And at a horizontal line at -4, all the y's are going to be -4s. No matter what x is, the y's are -4s. That's why it looks like that. And then 1. Here's where x is going to be greater than or equal to 1, so you plug it into the third. F of 1 goes into 4 times x plus 1, so 4 times 1 plus 1. So f of 1 is 4 plus 1, so f of 1. Okay, right here it says 53 and 55, we're only doing a walkthrough. Now, in coaching games, a walkthrough means we wouldn't really go full speed, it's just kind of taking you through the steps. More like a discussion, not going to actually do them. And hang that on you. When in doubt, really focus and try to decipher the directions. Language. In 53 to 56, find all the values of x. So you're solving for x. Find all the values of x. Such that the function f of x equals 0. In other words, you're going to take this function, basically, such that what they want is, what does x equal when f of x is equal to 0? Well, this is your f of x. They want you to let that be a 0. That's just a 15 minus 3x. They want that to be equal to a 0, and you're solving for x, so you're just going to replace this f of x with a 0, and you're going to set it equal to 15 minus 3x. And then you solve that equation for x. That's all. Let the equation equal 0 and solve for the x. And what you're finding, when y is 0 on the x-axis. All of the y is zeros here on the x-axis. When you let y equal 0, you're finding the x-intercept of the graph. When you let y equal 0, you're finding the x-intercept, where it crosses the graph at the x-axis. If you let x equal 0, you're on the y-axis. If x is 0, you're on the y-axis, which means when you let x equal 0, you find the y-intercept. So important information about when they say find the x-intercept and the y-intercept. When you find the x-intercept, you're going to let y equal 0. You're going to find the y-intercept, let x equal 0. 55 versus 56, they're fractions. I'll show you 56. Because 56 and 55 are identical, basically. When you have a fraction like 56, and you're supposed to let the function equal 0, let's do what I told you about, the last couple of weeks. If you have fractions, undo the fraction, multiply every term by the least common denominator. Or you can also use that whole, everybody likes to say, let's cross multiply. You like to use that word. But the bottom line is, we have fractions because we have denominators. Denominators mean division, and you undo division with multiplication. So if I multiply both sides by 7, 7 times 0, 0. That reduces. Guess what? The only thing that's going to make this rational expression, rational means ratio, ratio means fractions. The only thing that can make this fraction be a 0 is the numerator. If the numerator is 0, the function equals 0 because 0 on the top over a number, that's when you get 0. As long as you're not going 0 over 0. But 0 over any number except 0 gives you 0. 0 in the bottom is undefined. You have a number except 0 over 0, that's undefined. So you just need to worry about what's going to make the numerator be 0. So on my 55, 9x minus 4. If that's 0, then you're going to have where the function equals 0.
Let's say, I think that's 2 to be 7 times 2, right?
If they wanted you to find where does the function equal 2, then yeah, you would put 2 on the side. Yeah. So multiply 7, you get 14 over here, 2x minus 3 is 14, but you're not finding the x-intercept anymore. You're finding where on the graph you get, what's the ordered pair, when y is a 2. You're finding the x when y is a 2. All right. Okay. So your first quiz question is coming from 31 through 46. Your second quiz question is coming from 57 through 66. Find the domain of the function. Find the domain. The only thing you have to be really worried about, the only thing that could possibly limit a function's domain. Because right now, here's how you want to hope. Here's what you want to approach every function. The domain, all real numbers. That's what we hope. The domain goes from negative infinity to infinity. And let's just go with that. Unless something bad could possibly happen. Unless something horrible could possibly go wrong. Unless you could possibly get, these are the bad things, a number over 0. If some x causes something you can plug in, makes the denominator 0, that's going to limit your domain. And you have to time out, we can't use that. So if I gave you a function like f of x was equal to 3 over an x. I can plug in 5, I can plug in -3, I can plug in 17, I can plug in 0.2. I can plug in everything, but except I can't plug in what? I can't plug in 0. If I plug in 0, it's 3 over 0, it's undefined. So there's a problem with my domain because if I use a certain x, we get a number over 0. The other one, if you have a radical, and it's technically a square root, but it works for any even root. any even root. So a square root, a fourth root, a sixth root, any kind of even root. The odd roots, all real numbers. You can take the cube root of a negative, the fifth root of a negative, take the odd root of any real number. But the evens you can't. You cannot take the square root of a -9. Because it's not a real number. It's an imaginary number. And we're sticking with real numbers. You can't take the fourth root of a -625. Because it's not a real number. You're not allowed to take fourth roots of negatives. Not allowed to take square roots of any sixth root, no negative. So what you have to be aware of is negatives inside even roots. Those will limit your domains. And for us, that's all we have to worry about right now. Those two possible things happen. So on 57, is there any way I plug something in here for x that is going to cause a denominator that's a 0 or a negative in a square root? No. First of all, it doesn't have any denominators in the function. You can't get a 0 in the denominator if the function doesn't have any denominators. It doesn't have any even roots. It doesn't have any square roots or fourth roots or sixth roots or so on. So there's no way I can plug something in that's going to give me any negatives or zeros in a square root. Or sorry, negatives in an even root or zeros in the denominator because it doesn't have those. Therefore, the domain is all real numbers. This is how we used to do it. But this is how you evolve with it. Domain is all real numbers. Okay. Now, all real numbers means if you're going to pick a number line, draw a picture of it, because you can sit down, everybody take out a piece of paper, and I want you to write down every single real number. I'll come back in a billion trillion years and you'll still not done, right? Because there's an infinite number of real numbers. So you can't do that. We can draw a picture of it on a number line. On a number line, you just shade the whole number line. You shade everything, draw an arrow going to the left, you shade everything to the right, draw an arrow going to the right, and it's going left to right forever. Well, that's kind of cool, but you don't want to turn in a paper with a bunch of pictures on it. Then you have these last two notations. You have inequality notation. So that's the less than's and greater than's. So domain is the x's. Down there forever. You know what, my bad. It's easier to go to the right first, just for a term of explanation. I think I just got it. If you go to the right forever, what do we use to represent forever all the way down? To the right. Well, they're positives, but what number are we going to have? Infinity, which you can never get to. That's going to positive infinity. And if that's positive infinity that way, that's negative infinity this way. So the x's on this number line, they're greater than negative infinity because there have to be to the left of negative infinity. And the x's on this number line, they're less than because they're to the right, sorry, to the left of positive infinity, which means if you put it together, they're in between positive and negative infinity. You never put equals on infinities. Because if you put equals on infinities, that means you actually are standing at infinity. And we all know that infinity is just one more over. And as soon as you think you're there, it's one more over. As soon as you think you're there, you've got one more over, because infinity is still over one more, at least. Infinity could be 10 more. Infinity could be infinity more. What's infinity plus infinity? Infinity. What's infinity divided by 2? Infinity. Okay. Now that's a lot to digest. So interval notation. Interval notation. This is the domain from negative infinity to infinity. And you use parentheses when you don't have equals. It's not an ordered pair. And how will we know that? The context of the question. The context of the question is, what's the domain? We're writing the domain as a set of x's in interval notation. And it's always on infinity, it's always a parenthesis, because parentheses means it doesn't equal. When you have equals, we'll be using brackets. If there's going to be equals. We'll see some. We'll see one. $59. Yeah. Did I write that wrong? I know I just erased it, but okay, whatever I wrote down, there's no radicals and there's no denominators. So domain is in. What did I write down?
Just a problem.
Yeah. What is wrote 57?
Yeah.
Oh, okay. My bad.
57, you start doing.
Okay. My bad. Right, 59. This is all right, 59. F of t, h of t. H of t is 4 over t. All right. So, okay, now we have a variable down in the denominator, and you know you can't have 0 down there, so therefore, if you were to say this, just using, language, using your words, if we were if somebody was talking to us like we were 3, use your words. The domain is all real numbers, everything and anything except you can't plug in 0. So if we were to write it out, the domain is all real numbers except t cannot equal 0. And this, you don't have to do all of this. I'm just kind of taking you through the process. The reason why I'm taking you through the process is because I remember being taught this. And they just gave us the problem to say, all right, find the domain. And they never explained how to, what in the world are we doing? They never worked it through with us. So I never really understood how to work it through until I had to figure out how to teach other people. So I didn't want to make the same mistake that my instructors made with me, just assuming everybody understood. So when you think it through, you can't have 0 down here. A picture will help send you to the next level. What that means in a picture, you're going to have all real numbers, but right here at 0, you don't get to plug it in, you're going to have a big open circle. And you get to shade everything to the left of the 0, and you get to shade everything to the right of 0. And that's what you will get to use, everything except the 0. Just as a number line. It's not a graph, it's not XY axis, it's just a number line. Inequalities. All of these x's are less than the 0. All of these x's are greater than the 0. Now, I know I'm repeating myself because it's part about emphasizing, not so much as repeating. Math is a language. The domain is the set of all the x's that are less than 0, or you can choose from the set of all the x's that are greater than 0. Or. The word or versus the word ands versus ors. And means you have an overlap. That there are some elements in one set and they are shared in another set and they are in the same set at the same time. Well, there are no numbers that are less than 0 and at the same time greater than 0. You can't be less than 0 and greater than 0. So the word here is or. You either have numbers that are less than 0 or you got numbers that are greater than 0. Or. So now, the interval notation. Down there is negative infinity. When you write your interval notation, you always look at your number line from left to right. So the domain would start parentheses, negative infinity, and it goes all the way to 0, but it doesn't equal 0, so it's a parenthesis. Let's go with crappy parentheses. OCD, okay? And on this side, all of the domain starts at 0, but not equal to. So it starts at 0. And it goes all the way greater than 0, so it's going to positive infinity, parentheses. So it's the interval from negative infinity to 0. And now there's something in the middle. Or the interval from 0 to infinity. Now we don't use the word or now, you got to use symbols. The symbol for or in mathematics is that cup, which means it's the union of the two sets. This little cup right here means or, means union. You join those two sets when you have a, you're joined together, you have a union between two people. You join them together, you join the two sets together, all of these with all of those. The upside down cup replaces the word and that's when you want an intersection of the two sets. And one of the most discerning words in all of mathematics are these two, ors and ands. It basically decides, they're powerful words when you do computer programming. If this or this, do this. If this and this, do this. If it's an or, only one part of the statement must be true. If it's an and, both parts of the statement must be true. Philosophical arguments. So that would be your answer. That's the domain. Everything from negative infinity to 0, not including 0. Union, everything from 0, not including it, all the way to infinity. That's 59. Number 60. S of y is equal to 3 times y over y plus 5. Okay. Not allowed zeros in denominators or square roots of negatives, even roots of negatives. So there's no square roots in that function, but we do have a y down below. We have a y in the denominator. The y in the numerator, well, not too bad. We can let the numerator be 0 all day long, so that's okay. But the denominator cannot be a 0. Remember, that doesn't mean you can't plug 0 in. That means it can't be the total of a 0. If I plug in 0, if I actually use 0, S of 0 is 3 times 0 over 0 plus 5. 0 over 0 plus 5 is 5. 0 divided by 5 is perfectly fine because that's the actual number. It's 0. It's not undefined. So if I plug in 0, that's perfectly fine. What you have to figure out by looking at it, what is going to cause problems if you plug it in for the y? What would make the denominator a 0? Negative 5. Who's going to cause trouble? Who do you not want to invite to this party? Negative 5 would make the denominator 0. Now, sometimes it's a little uglier. So a good technique is you just look at, all right, you down here, that y plus 5, you better not ever equal 0. And if you do, subtract 5. So that means you better not ever equal negative 5. So all real numbers except the negative 5. And again, I'm going to take you through the number line because the visual, for me, the visual helps. I would have a number line, with my 0, but over here at negative 5, you'd have a little open circle, and you could shape everything to the left of the negative 5 and everything to the right of the negative 5. Everything except the negative 5. So from left to right, negative infinity, and it stops at negative 5, and you can't equal it, so parentheses. And we're going to join this set with that set, or union. The right side starts at negative 5, but not equal, so parentheses. And it goes all the way to infinity. And there's your domain. Now, before I do 61, I need to insert an extra problem so we can talk about it. So we're going to do number 60.5. Because 61 and 62, 61 is a cube root, 62 is a fourth root. You got some crazy stuff in there. So that kind of takes us a little faster than I think we want to do. Let's just talk about a simple square root. So we have f of x equal to the square root of x minus 4. So, first of all, you always hope it's going to be all real numbers. And the only thing that's going to mess you up is 0 in denominators. Well, that doesn't have a denominator, so we're safe there. Or negatives inside even roots. Okay, that's an even root. So you can't have the square root of a negative, which means the only thing that the x minus 4, if it cannot be negative, x minus 4 better not equal a negative. Well, it's kind of hard to solve it. Not equal to a negative. I don't know what to do. If it can't be negative, what can it be? What else? Undefined. Okay, well, that can get undefined because it's not a fraction. But if it can't be negative, it could be positive and or 0. See, everybody forgets that 0 doesn't have a sign. You got positive numbers, you have negative numbers. 0 is not positive or negative. Okay, it's kind of like the neutron in an atom. Protons are positive, electrons are negative, but neutrons don't have a charge. 0 doesn't have a sign. In mathematics, I remember teaching this when I teach in high school. We would always say it's non-negative. X minus 4 needs to be non-negative. Why don't they just say positive? Well, if you say positive, you're not including 0. So it's got to be non-negative. How do we write that? We write this as x minus 4 has to be greater than or equal to the 0. It's okay to be the 0. That's what non-negative means. Greater than, it's going to take care of the positive part of it. Equal to, it's going to take care of the 0 part of it. And then you solve it. Huh? X minus 1, this inside, all of that has to be, whenever I plug in, that difference better end up being bigger than or less than a 0. So what does X get to be? And 4. That means the X's that I choose have to be bigger than or equal to a 4. A number. So now on the 4, because it's got equals, it would be a closed circle, a closed dot. Greater than 4 is to the right of 4. So you would change everything to the right of the 4. That's what it looks like. Those are the only numbers you're allowed to plug into this function. So now, just so you can see, over here, if I tried to plug in 3, if I tried it, it's not in the domain that I think the domain is. 3 minus 4 is -1. So if I try to plug 3 in, I'm taking the square root of -1, which is not allowed. Which makes perfect sense because my domain better be this side. So now, domain from left to right, they start at 4. And it goes to positive infinity, but because you have equals, this is a bracket. When you have equals, it's a bracket. And then it goes all the way to positive infinity, and infinities are always parentheses. Now, my Algebra 2 by Math 103 class is doing a little bit of this interval notation stuff right now. And here's the problem is we used to teach Math 201, the Algebra 1 version of it all. We don't teach that anymore, unfortunately. But in that Math 201 class, we actually taught interval notation. So then they come to Math 103 and they already knew it. Now I got to start from scratch and teach them how to do this. And I don't know if you guys do it yet, but this is what I try to help them with. When you just have like this, X has got to be less than the -5. Over here, X has got to be greater than the -5. The less than and the greater than. There's no equals. If you're kind of lazy, that X, if you were lazy, almost that greater than almost could also be like a parenthesis. A parenthesis, no equals. But when you have greater than or equal to, less than or equal to, it's got that little down here and got one of those lines down there. So that's when you use the brackets.
Isn't it just like close the circle? Isn't that just equal?
That's what the closed circle means. That's when you graph it, you use the closed circle. But I'll tell you that the problem is I still get questions from that class going, when do you use bracket? So I try to get them some way to latch on. You know, and they still put brackets on parentheses. Even though I, kind of like a mantra, no parentheses, no brackets on parentheses, because you can't get them, never equal. But that would be the domain. From 4, including 4, all the way to 10. So now, 61. Oy. The f of x is the cube root of x minus 4. Okay, the only bad thing is going to happen to denominators with a variable in it or even roots with a variable in it. Well, that's not an even root, that's an odd root. You can take an odd root of any real number that you want. You can take the odd root of rational, irrational, positives, negatives, zeros, fractions. So the domain of this is just negative infinity, well, that's it. Negative infinity to infinity. Because it's odd. Okay, that's it. Because you, by looking at it, like if I was to look at this one and 58, that's a polynomial. There's no denominator. Nothing's going to cause us to go bad. All real numbers. Same thing here. There's no denominator. There's no radicals. Negative infinity to infinity. Okay. Odd roots. I can plug in anything I want. Negative infinity to infinity. All real numbers. But 62. The fourth root has some issues. You cannot plug a negative or take the fourth root of a negative. So that means what's inside that x squared plus 3x better not equal a negative. It has to be greater than or equal to the 0. Now, when we were solving these things in Algebra 1, not the inequality, but just an equation. The way you solve an x squared problem is factoring. Factoring. The first step when you factor is you always want to take out, if there is one, take out the greatest common factor. X squared and 3 times x have a common factor of an x. There's an x in each of these terms. So I want to factor out x. So that means I'm going to have x times x squared, x times x plus 3. And that's got to be greater than or equal to 0. Now, this is what you probably have done. You've done the equals part. Just equals, where you let x equal 0 and you let x plus 3 equal 0. And then you solve. You've done the equals part because that's what we're at here. And that's when the function equals 0. So right there, solve for x, and right here, subtract 3, and we get -3. That would make zeros. So if I plug in 0, 0 squared, 0, 3 times 0, 0, I get 0. If I plug in -3, -3 squared is 9. 3 times -3 is -9. 9 minus 9, 0. Those make my zeros. But what about the greater than or equal? You don't do this over here and go, hey, x greater than or equal to 0, x plus 3. You don't do that. Don't do that. Here's what you do. Think. This is what makes your zeros. Right here at 0. And because 0 is perfectly fine, 0 works, it's a closed circle. You're allowed to use 0 because it's got an equal. And -3 is perfectly fine. So over here at -3, you have a closed circle. So what you've got to do now is you've got to figure out what else works, because now you got to take care of the inequality. And it's this: x times x plus 3 greater than or equal to the 0. The number line is how you set up, and this is called, basically it's called a sign test. Greater than means positive. If I plug something in, it needs to be positive, and we're perfectly okay to take the fourth root of a positive. So all you gotta do is you have three intervals here. These two numbers on the number line divide this number line into three pieces. Less than the -3, in between the -3 and the 0, and greater than the 0. Just pick a number over here. Pick something that's less than the -3, anything. -5. No matter what you pick, if one thing works, then all of them work. If it doesn't work, then nothing works. If I use -5, and I don't care what the answer is, if I use -5, this x would be a negative. -5 plus 3 would be a negative. -5 plus 3 is -2. That would be a negative. I have a negative times a negative. That's a positive. Is a positive greater than or equal to 0? Yeah. So if -5 in here works, it's greater than or equal to 0, then everything this way is going to work. Those are the parts of the domain. Now pick a number between -3 and 0. Anything. So -2. So this is still going to be a negative because it's a -2. But -2 plus 3, that's a positive 1. It's a positive. A negative times a positive would be a negative. Is a negative greater than or equal to 0? No. If one value between -3 and 0 doesn't work, nothing is going to work. So there's nothing in the domain from here. So now you just need to pick something over on this side. Give me something bigger than 0. Pick one. You can pick 37,394. I don't care. You pick one. If you pick one, that's a positive. 1 plus, that would be positive. A positive times a positive is going to be greater than or equal to 0. So if this works, everybody this way works. Right. And so you would say, hey, the domain is all real numbers except between. No, you would say the domain is -infinity to -3. And there's a solid circle here. So that's a bracket. Union 0, because there's an equals, a bracket on 0 all the way to infinity. All right, everybody's here, so roll's taken care of. The quiz on Monday is going to be one question from the substitutions and then one question of find the domain. All right, have a good weekend. Now we'll finish these examples for 1.3 on Monday as well.